OAuth versus JWT is the internet's favorite authentication argument, and it is a fake argument. These two are not rivals. They are not even the same kind of thing. One of them is a flow, a set of steps for getting permission. The other is just a shape for a piece of text. Comparing them is like comparing a job interview to a paper badge. Over the next few minutes, we are going to write both in real code, and the confusion will simply disappear.
Here is the whole idea in one picture. There are two separate questions. Question 1. How does an app get permission to act on your behalf? That is OAuth. It is a protocol, an agreed sequence of steps between parties. Question 2. What does the resulting permission slip actually look like as text on the wire? That is where JWT might show up. It is a format. A protocol and a format sit on different layers. They never had to compete. Let's watch OAuth do its job. You click Log in with Google. The app never asks for your Google password. That is the entire point of the thing. Instead, your browser gets redirected to Google. Google asks you, "This app wants to read your email address. Is that okay?" You say yes. Google sends your browser back to the app with a short one-time code. The app then trades that code privately, server to server, for an access token. Redirect, consent, code, exchange. That is the whole dance.
Here is that exchange as real code. This runs on your server at the redirect address you registered with Google. Google hands you a code in the web address, line by line. You post that code back to Google's token endpoint. You include your client ID and your client secret. The secret is what proves the request came from your server and not from somebody who copied the code out of a browser address bar. Google replies with a small block of JSON. Inside it is an access token.
So what actually came back? Notice that the protocol never said. It might be a long random string that means nothing at all. Your server has to look it up in a database to find out who it belongs to. That is called an opaque token. Or it might be a JWT, a JSON web token. 3 chunks separated by dots: header, payload, signature. The first 2 are just readable JSON, lightly encoded. The third one is the wax seal.
And you can make one of these yourself with no OAuth anywhere in sight. Watch. You build a small dictionary, who the user is, when it was issued, when it expires. You sign it with a key. That is it. That is a JWT. On the way back in, you verify it. The library recomputes the signature using the same key. If a single character of the payload was changed, the seal no longer matches, and it throws an error. No database, no round trip to anybody.
And that is exactly where people get hurt, because reading a token and trusting a token are two different operations, and the library will happily do the first one for you without complaining. If you decode without verifying, you are letting whoever holds the token tell you who they are. There is a famous version of this bug. The token itself claims, "My signing algorithm is none," and a careless server believes it.
Here are the 2 calls, side by side. The top one turns signature checking off. It looks like it works. It even returns a user ID. It is completely worthless. Anybody can type in any user ID they like. The bottom one is the real thing. You pin the algorithm, so nobody can talk your server into accepting a weaker one. You check the audience. Was this token even meant for my service? And you check the issuer. Did it come from the party I actually trust? Now, the price of being self-contained. A JWT needs no lookup, which is the whole selling point. And it is also the whole problem. Because you never call home, you also never find out that something changed. A user clicks log out everywhere. An administrator fires an employee. You rotate the signing key. The token sitting in an attacker's hand does not care. It is still perfectly signed and not yet expired, so it still works. There is no kill switch.
So you buy that window back with 2 moves. First, make the access token short-lived, minutes, not weeks, and hand out a separate, long-lived refresh token that only the token endpoint will accept. Second, keep a small deny list of revoked token IDs in a fast cache and check it on the way in. Yes, that is a lookup, but it is one tiny cache read against a list that is almost always empty, not a full user record fetched on every single request.
And here is the arithmetic that decides your setting. If your access token lives for 30 days, then a stolen token is good for 30 days. If it lives for 15 minutes, your worst case is 15 minutes, and the refresh token that renews it is the piece you can actually revoke, because that one does hit a database. Short access token, revocable refresh token. That is the whole trade in one line.
And now the argument genuinely ends, because all 4 combinations are running in production right now. OAuth handing back an opaque token, that is how several very large providers do it. OAuth handing back a JWT, extremely common. Your own login form, no OAuth at all, minting JWTs, also extremely common. And your own login handing out an opaque session ID, that is the classic cookie session. 2 independent choices, not one fight.
So the whole thing in 4 lines. OAuth is how an app gets permission without ever seeing your password. A JWT is what a permission slip can be shaped like, signed, self-contained, checkable with no lookup. Decoding is not verifying. Pin the algorithm and check who the token was meant for. And self-contained means hard to take back, so keep it short-lived.
If that finally made the difference click, hit like and subscribe. One concept, all the way down to the code, every time. Next up, what a refresh token actually is and why rotating it is the part almost everybody skips.